I want to start by showing a video. No, just kidding. So, so first of all, I want to thank Jim and crew for organizing another Elixir conference. Woohoo, yeah. I want to thank all of you for coming. I hope you had a great first day, and you're going to have an even better second day. I also want to thank Platform Attack. We decided to invest in Elixir in the community, and that has happened almost 6 years ago. And we are really proud of how the language and the community grew. So that's really exciting. And one of the things that we have done as a company is that we have always helped companies throughout the different adoption stages of Elixir. So companies at the very beginning where they're still having a lot of dilemmas and they're still not sure if they should adopt Elixir or not. And then some companies that they already had a prototype or they even had something in production, we were able to go and talk to them. And what is really exciting about this process is that as we would go and take part in different projects, do different consultancy gigs, we would get a lot of feedback, right? And we get this feedback and we put back into the language, put it back into the community. So a lot of questions people would ask, then it became clear, right? Wow, we need to improve the documentation around this, and we would improve that. Or some feature is confusing, some of the APIs are not clear. We have to improve that. So it was we always had this very healthy cycle happening. And with time, right, the problems, they start to get advanced enough that you need a more streamlined story. Quick patch in the documentation or improving API is not going to fix it. So as we're doing projects lately, we're starting to see more advanced questions, more harder dilemmas to talk about that sometimes they're not specific about the language, but about the community or about the Erlang as a whole, right? So we were doing all of that, and at some point I called, and then after doing that for a couple of times, patterns, they still started to appear. They're just harder patterns to solve and to address. So I called Bruce, was just doing the presentation here, and I said, look, I'm starting to see all of those dilemmas now coming up, and I think it would be really helpful for Elixir adoption if we address those dilemmas and we talk about it. But we need to do that in a more structured way. And then Bruce said, that's great news, because I just received a proposal from Ben Marks, which is Ben, all right? He's there, apparently a little bit shy. And he said, I just received a proposal from Ben where he's describing how has been the adoption process of Elixir inside the Bleacher report, which was one of the early adopters of Elixir, and they're running Elixir at a large scale. So we decided to talk about it. We got all three of us together, and then we decided to write a book. And the book is called Adopting Elixir. We are going to have a beta coming out in a week or two. And we're really excited about this book because we are trying to tell different adoption stories. We're telling the Bleacher report story, or telling the Bruce adoption story at I Can Make It Better. And I'm relaying a lot of the experiences that I've got from the community and from different clients. And we are trying to talk about all of the topics, from the beginning, for when you have this concept of a product, of an idea where you want to use Elixir, and then to development, and then to production. So I'm hoping that this can help companies decide if Elixir is the proper tool for them, and if it is, speed up that process. So that's one of the things that's coming out soon, and we're really excited about it. Something that I also hope is going to help a lot the Elixir adoption, and this one is already out, is Elixir 1.5. Okay, so it was released kind of a month and a half ago, and we have almost 600 contributors throughout the whole language lifetime. And again, I always say that, right? Those are only the source code contributors, but there are a lot of different ways to contribute to the language by talking at your company, organize a small meetup, writing a book, writing a blog post, and all of those are extremely welcome. It just happens that this one is the easiest to track by far, right? So, and then other ways to contribute is with Hex packages. We were getting the numbers yesterday, and we talked about it. So we have almost 5,000 packages, and overall, more than 120 million downloads. Yeah. So, but there's one thing that makes me very excited about Elixir 1.5, which is there are two features in particular that makes me excited, not only because it improves Elixir adoption, but in order to get those features out, we have to contribute and collaborate with the OTP team, and that was a very nice experience. So the first feature is that now we have Unicode atoms, vars, and functions. Okay? And this does not mean you can use emoji in your function names and your variable names. I'm sorry, I know that some of you are disappointed by that. What we have actually implemented is, so the Unicode, they actually have a spec that defines how languages should implement Unicode support, and then we follow that spec. And it's focused exactly around written languages and not emoji support. And what I'm excited about it's because I think it can help, I'm sure it's going to help the Elixir adoption at non-English speaking communities, right? Because at first, you can think like, why I'm going to use a variable name in another language or a function name. But it's important to remember that a lot of the things in Elixir, because the language is extensible and you can metaprogram stuff, they end up being compiled to functions or they end up being compiled to variables. So for example, every time you define a test and you have a string saying what that test should do, right? That's going to be compiled to a function. And then if that, in the function names, they do not support Unicode, it means you cannot write a test using a word or a notation from from a language that is not English, for example. So I couldn't use things for Portuguese. I think one of the early reports about needing this feature was someone that they were writing a test, and in the test name, they had the euro sign and the pound sign. And then they're like, the test would not compile exactly because of this limitation. So I think this is going to improve the Elixir adoption in other communities, and this is very exciting. And in order to implement this feature, we sent this pull request to the OTP team that has been merged and accepted. And the idea of the pull request is the following. So every time you define a module in Elixir, and you compile that module, it generates a bin file, okay, a bin file in disk. And this bin file, it's split into a bunch of chunks that has metadata about the code, about the module you just compiled. And one of those chunks, they have the atoms in that module. All the atoms, it's defined there. All the atoms, they are defined there. And previously, that chunk was written in Latin 1. That's why we did not support Unicode. So the whole work behind this pull request is to introduce a new chunk where the atoms, they are encoded in UTF-8, and now we can allow them to be anything. Okay, so that's a nice addition, and that's why to use this feature, you need to use Erlang 20, Elixir 1.5 and Erlang 20, because it has just recently merged. And the other feature that I'm really excited about, and I'm going to show it because, all right, spoilers there. All right, so I'm not confident. All right, one more try. In the back? Beautiful. All right, now I'm confident. So this feature in particular, exception blame, so let me show you how it works, right? So the way the exception blame feature works, it's a function, but we are starting to use this function in Elixir in a bunch of different places. And one of the places where we're going to see this exception blame thing working is, for example, if you try to call a function passing an argument that function cannot handle, okay? So for example, if I call this code accessFetch foobar, we get this beautiful exception now, okay, that says, so at the beginning it says, we got a no function clause error, right, when trying to invoke the accessFetch function, okay? And now we list explicitly which arguments we are trying to pass to the function. And not only that, we show of all the clauses in that function, why they failed and why the code did not work. So you can see that, for example, it did not match this first clause exactly because we were expecting a struct kind of thing right? And we passed an atom, so that's not going to match. So we do that for every clause. So now it's very easy. If you have a function clause error, you know exactly which arguments you're passing and which clause we try to invoke and why it did not work. In previous Elixir versions, if you're not familiar, all this thing that I'm going to select right now, it was not part of the exception. Right? So previously, it would just say no function clause error. Right? And then the arguments, they were actually in the stack trace, so we had to dig them out of the stack trace, and you had to figure out why it did not work. And now we're able to show a lot more information. Okay? So this is going to improve a lot of development experience, right? Because sometimes it was really hard to figure out what went wrong, which arguments you're invoking, and so on. And another feature that we added in Elixir 1.5 is that now we can set breakpoints directly from IX. So for example, I can set a breakpoint in the URI, the code query function, right? And now when I call it, passing, for example, a string to the code and the initial argument, it's going to say, hey, I reached the breakpoint. And then from here, we can access the variables from that breakpoint. So I can access the query, I can access the map, and we can do a lot of interesting stuff and continue debugging and move forward. So those are really nice features that's going to make all of us more productive. And what is very interesting about this is that, so Elixir 1.5 was released in July, right? Just kind of 1.5 months ago. And if you had asked at the beginning of the year, when we started to prepare the work for Elixir 1.5, if you had come to us and asked, hey, can we have, when I have a function clause error, can I have a better error message that tell me what went wrong? We would have told you, this is a great idea, this is a great feature, but implementing this would be too complex and error-prone, okay? And then if you ask, hey, can we have breakpoint debugging in IX, we would say, that's a great idea, but implementing it's definitely going to be too complex and error-prone, right? But something happened, right? Because those features, they're there in the language. And exception blame, we implemented over 2 days, and the breakpoints over 3 days. So we implemented them actually quite fast. And what happened is exactly that this pull request was merged into Erlang. And it's very similar to the previous one. We are talking about chunks. So remember, every time we have a module and we compile that module, we have a bin file, and that file has a bunch of chunks with metadata about the code we just compiled. One of those chunks, one of this metadata, is exactly the source code. But the source code represented as Erlang nodes. Okay, so what would happen is that we have Elixir, we would compile that to Erlang, and we would store that code representation of the translation of Elixir to Erlang into the bin file. And the reason we do that is because a lot of the tools that we use, like Dialyzer, Cover for coverage reports, the visual debugger, all of those, they rely on this Erlang chunk, okay? So we started to think, well, it's great that we can rely everything that the Erlang ecosystem has to provide. But for example, if you have used coverage in large projects, you know that sometimes the coverage is a little bit off. There is a line that it does not cover. It does not say, even you are testing it, it says you're not testing it. So in some places, a little bit of information is lost, exactly because we do this translation from Elixir to Erlang. And if one day we would like to have cover tools that are specific to Elixir, it means we need to have the Elixir version of the source code as well stored in the bin files, right? So when we were thinking about this, we're really thinking about the future. Maybe one day we'll need it. So we say, okay, how are we going to solve this problem? And one of the things that we could do is that we could just add the Elixir source code representation to the bin file and have the Erlang source code representation there as well. But the issue with that is that in most of the bin files, the Erlang source code representation, they're already half of the size of the bin file. So if we add the Elixir one, we are going to grow a lot how much space the bin files consume. So we thought about it, then we said, wait, so what if instead of trying to have the Elixir one and the Erlang one, right, what if we introduce this abstraction where we say, instead of saying that we are storing Elixir code in the bin file, instead of storing the Erlang code in the bin file, what if we store this metadata? And then if you want the Erlang representation out of this metadata, you are going to ask this metadata, hey, can you emit Erlang code by any chance? And then if the metadata can do that, then it's going to emit that. Otherwise, it's going to say, sorry, I can't. Okay? So we've introduced this small abstraction. Okay, I like to say that abstraction, they're like Oreos, right? The more layers you have, the better it gets. No, not a thing. But so we introduced this thing, right? A very thin wrapper around this metadata. And now when you're using Erlang 20, what we store in the bin file is this metadata that knows how to emit Elixir if you want to, that knows how to emit Erlang if you want to. Okay? So we send this pull request, we change it Elixir, okay? And they're like, this is going to be really useful in the future. And then someone asked the question that I just said, right? Someone came and said, hey, what if the function clause error, it actually shows more information? And then we're like, that's a great idea, but it's going to be very and then wait a bit. Now we store the Elixir code in the bin file, which means that if you try to invoke a function and you get a function clause error, we can actually get the Elixir code from the bin file. We can try to see exactly which code you're trying to call, which clauses, and we can figure out exactly why that did not work. So something that was going to be complex and error-prone now became really straightforward. And the same thing happened with breakpoint debugging. Someone asked, can we have breakpoint debugging? And then we realized, yes, we can. So we just need to get the Elixir code from the bin file, and then we add the breakpoints, and then we compile that code again. Okay? So right now, the situation that we have as a community and as the Elixir core team is that we now have a new door full of possibilities open in front of us because of this small change. Right? So for example, last month, Brian Joseph for ElixirScript, he released the new ElixirScript version. And that ElixirScript version, what it can do is that if you call, for example, list.last, which is a module and a function that ships as part of the Elixir standard library, if you call that in your ElixirScript code, ElixirScript is going to get the module from the Elixir standard library, is going to get the Elixir code, and is going to compile that to JavaScript. Right? So previously, what he was doing is that he was rewriting the whole Elixir standard library in JavaScript. But now he doesn't need to do that anymore. He can just go and compile everything dynamically as you need it. Okay, so that's really exciting. It's a new exciting possibility. So what we have in front of us is this new door, right, with full of exciting possibilities coming out of it. Right? And one of the things that we need to do is that now we need to choose of all those possibilities, which we don't know yet. We are sure they are there. Right? We don't know everything that we can do yet, but we are sure that all those new possibilities, they are coming. And we need to prepare, right? Because we need to choose. We need to choose which one of those features, which one of those possibilities we want to explore, which one they are going to reflect better on Elixir as a programming language and on us as a community. Okay? And choosing is very important, right? Because what I envision for Elixir is that if someone comes and asks, as an Elixir programmer, what do I need to know? What are the techniques, the idioms that I need to know as a developer? I want to say exactly the techniques and idioms that are in the language, right? So there's only a given amount, and that's it, right? Give or take small things, but that should be what's in the language. Right? So that means that only a finite amount of things that Elixir should have as a programming language. Right? We cannot have everything, because if we have everything, if we put everything in the language, then the language becomes big to the point where people they will start to use only a subset of the language. Right? Then people, they're not using 95% of Elixir. They're using only 70%, and then there's that 30% that part of the community don't really like it. And then there is another part of the community that really likes that 30%, but does not like that other 30%, right? So that's not what we want. And what is really exciting about Elixir is that we can actually afford to do that, right? Because Elixir was built on the idea of being an extensible language. So if there is a feature, which is a really nice feature, imagine that there is a feature that is really nice, but we say, this is really nice, but we don't think it should be part of the language. We can actually say that, and if we do that, we are not taking that feature away from the community, because the community can still go and implement that, right? Because a lot of Elixir is written in Elixir itself. The same constructs that we have to implement the language, they are available for developers to extend the language, okay? So what it means, right, is that we should choose, right, of everything that, of all the features that we can possibly implement, we should focus on the ones that we think they really matter. So that's our challenge, right? So that's the challenge that's ahead of us. And how has we tackled that all this time, okay? Because, you know, Elixir exists since the first commit where we decided to invest in Elixir, it's going to be almost 6 years, right? So it means we have chosen all this time, we have had some guidance. And the way we did that was using Elixir goals, okay? So back in 2012, when we started to work on the language more intensively, I said, okay, I need to focus on what I want to see as part of the language. I outlined the Elixir goals, the goals of the programming language. And we have 3 goals, okay? They are productivity, extensibility, and compatibility. So productivity, so let's see examples of those goals, right? How they end up being reflected in the language today. So productivity, it's a lot about the tooling, right? So we want to have very good tooling because that's going to make developers more productive. So we're talking about Mix, IX, Observer, which is a fantastic tool that comes from Erlang. We're talking about first-class documentation. And to me, first-class documentation is productive in 2 ways. So the first one is when I'm using someone else's library and it's well documented, then I'm going to be productive because I don't need to fiddle with the source code, okay? But the other way, I am personally productive in this first-class documentation approach. It's because it works kind of like rubber duck debugging, but for development, right? So rubber duck debugging is when you have an issue, you imagine there is a rubber duck in front of you, or fictional friends. Some people, they actually have a rubber duck in their table, right? And then you explain the problem to the rubber duck, and in that process of explaining the problem, the solution becomes clear, okay? So to me, I use a lot of that, but for development. Sometimes when I need to work on a new function, and I'm not exactly sure how I'm going to call that function, or not exactly sure how I'm going to name the arguments, I write the documentation first. And in the process of writing the documentation, it works as if I'm explaining what that function does to somebody else. And then the name becomes clear. The arguments, they become clear, okay? So first-class documentation, collections and strings, the whole approach Elixir has for collections, where we have the num module that can work with a large variety of data types, and then we have the string module that adds laziness on top of that. It allows us to be more productive because we don't need to learn a bunch of different APIs. We can focus on those 2 places, and they mirror each other a lot, right? The whole approach with strings is strings being UTF-8 encoded by default. Okay, it helps a lot, especially if you're building anything that is related to a user interface somehow. And also multi-core processing, right? And another multi-core processing, we could talk a lot about a bunch of different goals we could put under multi-core processing. But I put it under productivity because even if you don't care about multi-core processing at all, if you don't care about processes and the reliability aspects that processes bring, the fact that Elixir is going to compile your code using your cores, that you can run the tests using your cores, right? That Hex is going to fetch the packages using your cores, right? That's going to make you more productive, right? Even if you don't care about that at all, it's just going to happen. So nice, right? So a lot of examples about productivity. Extensibility is the second goal of the language, and I've already mentioned extensibility a couple of times in this talk, right? It's a really important goal for us. And in Elixir, it reflects in 2 ways. So the first one is macros, and macros are about compile time extensibility, okay? We are about to extend the language when we are compiling our code. And it's one very important aspect on how we can get Elixir and extend to different domains, okay? And the other aspect of extensibility, they are the protocols, the language protocols. And I like to say, and that's about runtime extensibility, because what protocols allow us to do is that it allows us to build large maintainable systems. Because protocols, they allow us to define contracts between different components of the system and allow the systems to be decoupled, right? So what I can do is that I can write a library, and or someone can write a library, and anyone can extend that library to a particular domain, because if that library exposes a protocol, all we need to do is to implement that protocol, okay? And the third goal is compatibility. And compatibility, at the time when we came up with this goal, was about, everything that exists in Erlang and the Erlang VM and OTP, we want to be able to leverage it from Elixir with no penalty, right? So that's why today we can call Erlang code from Elixir with no performance cost, right? And we have all the abstractions that they exist in Erlang. We can leverage them directly in Elixir. So here we talk about isolated processes, right? And everything they bring in terms of reliability and fault tolerance. So we are talking about fault recovery with supervisors. We are talking about distribution, okay? We want to leverage all that. Okay, so to sum up the talk so far, right? So we talk about what is in Elixir 1.5, and then we figure out that we have this new door of possibilities in front of us. And then we said, well, we need to choose which one of those we want to pick and we want to explore in the future. And the way we have been doing that all this time is we use Elixir goals as a guide. So we can basically continue using Elixir goals, right? It seems to have worked out well so far. So we can continue doing that. But we decided to think a little bit more about this, right? So for example, at Platform Attack, one of the things that we do as a company is that we have our values as a company and that the employees, we all follow. And those values, they're public, they're on our website, you can go and check them out, and we have 9 of them. Of course, we value more things, but again, we need to choose, right? Because if we value everything, then it means we value nothing, because we're not able to choose. So, but one of the things that we do is that every year we have a meeting with all the employees. And what we try to do is that we try to come up with evidence that we are actually following those values. Okay, so we try to come up with examples on our day-to-day or in a particular project where we are following those values. And sometimes it may happen that one of those values, we do not have evidence. We could not come up with evidence that we were doing that. And sometimes it is because we started to value something else. So we need to figure out, what is this new important thing that we have been valuing our everyday that replaced the old one. Or sometimes because we did something wrong. That value was actually important, and we stopped doing that, and we should actually go back to doing that. But basically, we need to go, so we have this retrospective where we need to go and think about our values. So I thought, what if, before we go on with this idea of continuing following with Elixir goals, what if we do the same for the Elixir goals? What if we try to come up with evidence that we have been continuing improving the language towards those goals? So that's what we did. And the way we did that is that we went through all the Elixir releases after 1.0. And I went through the changelog. I got all the important features in the changelog. And then we tried to classify those features and see if they fit in one of those goals. So for example, productivity, it's very clear that we have been working version after version on making developers more productive by, for example, improving the tooling. So examples are, in Elixir 1.3, we have the mix test --stale. Who is familiar with this feature? Who uses it? Okay. So only few use it, which is very good news because you have now a new exciting feature to use when you go back home, right? So what this feature does is that, so imagine you run your test for the first time, mix test stale, with the stale flag. And now when you change your code, mix test stale is going to run only the tests that have been affected by that code change. And the way Elixir figures that out is that it does not use a file name mapping, none of that. It actually uses the same thing that the Elixir compiler uses to track changes. So we are going to only run the tests that are guaranteed by the compiler to have been affected. Right? And this really improves a lot the workflow, because if you are testing a lot and running the tests, which you should be doing, right? You are developing and running the tests, this is going to guarantee, right, that it's going to guarantee to run only the tests that matter, okay? And you don't need to be running everything all the time. So that's really nice. One of the features that, this one is a little bit clearer, a little bit more in your face, is the XUnit diffs. So if you have using Elixir 1.3, onwards, like every time you run the test and you are trying your assertion compare left to right, we now show a diff in red what is different between the left side and the right side. And that's, after you use this for the first time, you really cannot go back to 22 that does not give you the diff, because it's really clear if you have a large string, right? It can say, hey, what is different here is this character. There's a typo somewhere, right? And really is to spot the errors and to fix those errors. Another really small feature that you spend all your life without using it, and then when you use it, it really changes everything, is IX syntax coloring. So the coloring of the data structures make everything easier to navigate. When we talk about concurrency, right, we said that the multi-core aspect helps a lot with productivity, and we have always improved things like async stream to give developers different ways of using all of the cores that we have available. And we were just talking about another feature, right, like IX, the helpers and the breakpoints, right, having those debugging tools easily accessible. It's a good tool for us to have that's going to make us more productive. So that's productivity, okay? So we have a lot of examples. But when it comes to extensibility, I was reading the change logs, and I had this final list, and I could not come with any example of us continuously improving extensibility in the language. But that does not mean that extensibility is not important, right? I mean, I have talked about extensibility a couple times in this talk already. It's extremely important for us. But what this means is that these worked as a goal to define Elixir 1.0. When we defined Elixir 1.0, we added macros, we added protocols, and they are the pillars, they're the foundation for extensibility in the language. And it's there. It's kind of like, this goal, we have achieved it, right? It's there in the past, and now we are building on top of it, okay? So I could not come up with evidence. I could not find evidence, actually, instead of coming up with them. I could not find evidence that we are continuously improving towards this goal. And compatibility happens something similar, right? Because compatibility means staying compatible with Erlang. And we are compatible with Erlang, right? There's nothing more to do that. Maybe, when Erlang adds a feature, we kind of like add that to Elixir as well. But there isn't much to do in that aspect. It's compatible, period. Okay? And even it's kind of like we started to stray away from this goal, because at the beginning, if you came to Elixir like a long, long time ago, before 1.0, and you said, I want to use a June server, we would say, well, so you should use the June server that is in Erlang and read the Erlang documentation, right? And then with time, we are kind of becoming more confident, and then we say, okay, we have our June server because we can do some improvements in some areas. We added tasks, we added agents. So we even started to go beyond this compatibility, and we started adding our own abstractions, with the latest example being GenStage, okay? So, so actually, we are not up to date in our goals. So we need to revise them. We need to think how we want the language to grow in the next 3-5 years, okay? And that's what I want to do now, okay? So for the rest of the talk, what we're going to do is that we're going to talk about the revised goals, and then we're going to see what is coming up in the future under the lens of those goals, okay? So what are our revised goals? So there is one that's very easy, right? It's productivity. This one did not change. We'll continue working towards that. There's probably a lot of work to do in this area, and we'll be glad to continue improving all the different aspects of the tooling, of the language, and so on. But what about the second goal? Does anyone want to guess? What should be? So we want to replace extensibility. Do you want to guess? What do you think, or what do you think? Don't guess. Like, what do you think in your heart, in your soul, that should be the next, how we should rephrase extensibility? Sorry? Adaptability, that's a good one, yeah. Anyone? Code? Stability, that's a good one as well. All right. So, anyone? Anyone else? 1, 2, 3. Approachability, yeah, very close to adaptability, yeah. So, those are all good ones. Okay, and I would say that approachability and adaptability, they fit very well under productivity, right? Because it's the aspect we do not only want the advanced developers, right, to be productive. It needs to be from the beginning to end, okay? But when we think a lot about productivity, right, what do we think about, right? We think about writing of the code, right? We want to write the code fast. That's usually when we think about productivity. Oh, I spent the whole night and I built this huge thing and it works and it's amazing, okay? But there is the other aspect, right, which is the reading of the code, okay? Which we, when we are working on a team, it's probably what we end up doing the most, right? We all say, we end up reading the code a lot more times than we write it, okay? So we want to explore Elixir under that light. And then when we think about extensibility, right, we had two things under extensibility. We had macros and we had protocols. And macros, we can easily, if we remove extensibility away, we can easily put macros under productivity, right? Because this ability of getting the language and extending the language to some particular domain, right, is going to help all of us be more productive. But when we talk about protocols, right, I said, that protocols, we can use them for building large systems and build maintainable large systems because we can define the contracts between those different components, right? And I like that word. I like that word maintainable, okay? It's even, if you go to the Elixir website, we say that Elixir is a functional programming language for building maintainable and scalable software. So what if we call it maintainability, okay? So what if we revise extensibility and say, now, it's really about maintainability. And we have features in the language that focus on maintainability. I think we do. I think we have a lot of them, right? So the first one are all those concepts that come from functional programming, like immutability and pattern matching. The fact that I can call somebody else's code and I have the guarantee that that code is not going to change the data structure, is not going to mutate the data structure I'm giving to it. Right? It makes the code a lot more readable because I need to worry less when I'm reading the code. It makes the code more maintainable. It's easier to understand what the code does, okay? Pattern matching as well, and I'm not talking about the structuring aspect of pattern matching, which is really nice, but I'm talking about how we use pattern matching as a contract between functions, right? File.read can return me an OK tuple or an error tuple where I can pattern match and decide what I want to do accordingly, okay? So we are talking about testing, and we have been continually improving our testing tools, okay? That's, if we are writing tests and we are pushing everyone towards a direction where they are writing tests, we are going to have more maintainable software. We talked about protocols and how protocols, they help us establish contracts between large systems, and that allows us to refactor components of our application because we have those explicit contracts. And I think a lot that helps with the maintainability is something a little bit less palpable, but is this philosophy that we have of explicit over implicit, okay? And it's interesting because we're starting to see some confusion about what explicit over implicit means. So someone was saying, well, if I like explicit over implicit, does it mean that every time I call a function, I should list all of the options that that function accepts so it's clear what I'm calling it? Or if I'm using somebody's library, I should not rely on convention over configuration and explicitly configure everything. And no, to me, that's not what explicitness is about. Because if you're doing that, if you're listing all the options, I would actually argue that the code is less clear. Because now for me to figure out what you need in special from that function or from that library, I need to figure out from all of the options which one you actually change and which one actually makes sense to your code or to your domain. Okay? To me, the explicit over implicit, it's about in face of complexity, right? What are you going to choose if you have complexity? Are you going to try to put that under the rug, or are you going to try to make that explicit for who else is coming to the code later on, right? And examples of where we do that, right, is exactly with immutability, right? Immutability is the default. So if you want mutability, which is complexity, right? Because if you have a lot of things change at the same time, it's really hard to understand what that system, what that code is doing, right? So what we do is that we have immutability by default, and then if you need mutability, you need to reach and get a particular tool. You need to use ETS, for example, okay? So that's one of the places where we're being explicit towards mutations. Another example, they are macros themselves. So we're just saying, macros is one of the powers of extensibility. They're really powerful. We can do a lot of interesting stuff with that. However, in Elixir, we do not allow you to have a file that is going to define a macro and that's going to magically change all the files in the code base, right? Or all the files of anyone using your library. That's not possible. Every time before you use a macro, you need in the same file, somewhere before you use the macro, you need in the same file to say, hey, I need to require this module. I need to import this module. So it becomes clear that, here may be dragons, okay? And you're making it explicit in the code, right? Things cannot change magically and affect your whole code base. And we're never going to add that to the language, okay? So yeah, so that's maintainability, right? And so we have a lot of examples in the language, and we actually have evidence that we have been working towards maintainability in the last releases. Yeah, we have a lot. So for example, mixxref. So mixxref It's a tool that we have in Mix, and we run it by default every time you compile our code. And what it does is that it checks if your code, if you are trying to call a function that does not exist, and it warns you about that. So something that before would be a runtime error, okay, now it is a warning that you can get after you compile your code. You don't need to run your tests to figure that out. You don't need to maybe wait and see that thing happen in production, which would be a disaster, okay? So that's going to help us write better code that works, okay, out of the box, right? So mixxref, it's one example. The deprecation of imperative assignment, right? So for those who are not familiar with imperative assignment, what you could do, and you can still do in Elixir today, but today you get a warning, right? But what you could do is that, for example, imagine that you had a case and an if and a case, and if you change a variable like 3 levels deep, it would change the value of the variable all the way up, right? So you could, in whatever level of nesting, you could change the parent scope, right? And that allows us to write really hard to read code, okay? So that's deprecated. So if you do that, you're going to get a warning that tells you exactly how you should write that code, okay? And we're talking about tests. So in Elixir 1.3, we added the named setups and describe, which helps us write more manageable tests, which is going to improve the quality of our software. And even in Elixir 1.5, we have a new feature, which is called the at implementation. So sometimes when you're reading somebody else's code, right, they have a module that is exporting a bunch of those functions, and you're not sure why those functions are there, why they exist, because sometimes those functions, they are an implementation of a callback. Right? So for example, if you're in a Phoenix controller, a controller may have a def action function, and you're like, why does this function exist? Right? And it exists because it's a Phoenix callback. With the at implementation attribute, you can actually say, hey, this thing is an implementation. And now when someone comes and they're going to read the code, it's going to be clear why that thing exists, right? And they don't have to guess, right? So I think maintainability is a good addition, right, to our set of goals. But now we have the last one, right? We had compatibility, and we need to make that, and we need to rewrite that a little bit, okay? And when I was asking about the goals before, someone actually kind of hinted to that, right? So compatibility, why do we want to stay compatible with the Erlang virtual machine, right? And everything that it offers, right? We want to stay compatible because of concurrency. That's one of the reasons. We want to leverage those concurrency tools. We want to stay compatible because of distribution, but we also want to stay compatible because exactly of those tools that allows us to write reliable and fault-tolerant software, okay? And every time we have improved, we had added new things like tasks and agents and GenStage, right? What we have been focusing was in reliability, okay? So I think that should be our third goal, right? So what are examples of reliability in Elixir? It's everything that we're talking about compatibility before. We're talking about isolated processes. And not only that, all the conveniences that Elixir add regarding managing those processes under the task module. We are talking about fault recovery supervisors, okay? That's still part of reliability. And we're talking about back pressure with GenStage, which did not end up being part of the language, but it's there and it's maintained by the Elixir team and it's available to everyone, right? And we actually have evidence that we have improved the reliability goals throughout the last releases. We do, right? So even back in Elixir 1.1, when we added task.yield and task shutdown, which really allows us to start a process that's going to do something and ask that process, hey, did you do the thing they were expecting to do, right, or not? Should I shut you down because you're not going to complete that in time? In Elixir 1.4, we added the registry, which allows us to identify and give names to processes that are dynamically created. And even in the next Elixir version, 1.6, we are going to add a dynamic supervisor, which is a supervisor that exists specifically for managing processes that are dynamically created. This is possible today, but it has a very confusing API, and we want to continue improving on that. And we want to improve this API and add new capabilities, okay? All right, so, so to recap, right? We released Elixir 1.5. We figure out that there are new possibilities. We're not quite sure what those are yet, but we are sure they are coming, okay? And we said, okay, we need to choose, right? What of those new capabilities they are important? And we decided to start with the Elixir goals, and we have revised them. So now we can say that the Elixir goals, they are productivity, maintainability, and reliability. What do you think? Those are good goals for our programming language? Cool. So now we have the last task, the last proof we need to do, right? So for the things we have been planning for the language, do they align well with those goals? And then it's going to change, right? For how can we describe the things that we have planned for Elixir 1.6 and beyond? How can we describe them in face of those goals? And what is really interesting is that, so every time I prepare a keynote presentation for Elixir conference, one of my dilemmas is like, how much into the future do I want to talk about? Okay, because what is coming in the next 6 months, what is coming in the next 1 year, right? I can easily talk about that with a lot of confidence, but when we start going beyond that, right, there's a lot of uncertainty, and it's hard to talk about a feature that may not actually ever come, okay, may never be part of the language. And the truth is that since Elixir 1.0, I had this list of features that I would like to explore, research, or eventually have those as part of Elixir. And with time, this list is getting smaller, right? Sometimes because we add those features to the language, so the calendar types that we had in Elixir 1.3, they were part of this list. The registry that I just talked about, it was part of this list as well. So it's because we're implementing a lot of those things. Sometimes it's because we figure out that that feature does not really belong in Elixir, so we kind of give up on it and say, okay, maybe someone in the community is going to need it and they can implement that, but it's not part of the language. And sometimes we even implement the whole thing, right? So GenStage is by far our longest research project and development project, and it ended up not being part of the language, and that's fine, right? Anyway, the point I'm trying to get to is that we have this list, and it's getting smaller and smaller and smaller, which is a good thing, to the point where I can talk about almost all those things and discuss them with you, okay? So research and development. So if we're talking about productivity, there is a feature that we are working on that I think is going to help productivity a lot, which is a code formatter. And we are going to, all right. And we are going to talk about it really soon. The second one that can help us with maintainability, those are property testing. And, all right. Less clapping for property testing. I'm taking notes. And focus on reliability, we have releases. And regardless of the language goals, there is something that, as it improves, it's going to continue adding abilities to Elixir as a programming language, and those are the improvements that help in Erlang and OTP, right? So that's kind of like a thing on the side that we are always tracking, and we are happy to continue working with the OTP team. And one of the things that we actually want to have in the future is cross-language documentation. So from the terminal, you should be able to access documentation from any language, okay? All right. So those are kind of the things that we have in store, and they are in different degrees of progress. Okay, so let's talk about those. So the code formatter, the most beloved, apparently. So code formatter, what does it do? It formats your code using a consistent style, okay? So we have all been to this discussion, right? Like, oh, do we have a style guide? How do I contribute to this project? Right? I have a friend, Xavier Noria, that he says that the best contribution is like a ninja contribution where you don't actually feel like you change the style of the code base, right? Which actually, it's always exciting to contribute to different projects, right? But if one of the things you need to worry about when you're contributing is exactly to read the style that the project uses and replicate that, okay, the contribution become harder to write. And sometimes there is no style, right? So when we were working the code formatter, so actually, even before working the code formatter, as more people starting to be part of the Elixir team, they would come and ask me, like, why did you use this style, this particular style here? And my answer would be, I guess I felt like it, right? Like sometimes we don't have a particular theme. We just have, oh, I think this looks better, so I'm going to add a new line here, or maybe I'm going to indent this way. So a lot of those things, they're not really rational, a lot of those decisions, right? So with the code formatter, a lot of those discussions, a lot of those aspects, it's going to be handled automatically for us by this tool, right? So for example, at Platform Attack, more examples, right? Platform Attack, we have style guides for all the languages that we use, and those are public. And when we have a new developer joining, learning a new programming language, one of the things that they need to do is exactly to learn that style guide, right? And then when they go to the first project, the reviewers, they need to remember to review the style guide as well of that new contributor because it may not be completely in line with what we do, right? So I was reading a lot about code formatter discussions. And my favorite quote, I actually have no idea if this is true, if this is an actual thing. But my favorite quote is that somebody said, you know, that's like when Steve Jobs, he used the same clothes every day. And he did that so he could focus on the big decisions and instead of focusing on the small ones, right? I actually have no idea if he used the same clothes every day, but it's a really, I think it captures the spirit, right, of being able to focus on what matters. So the code formatter is going to help us not have to worry about should I add spaces after parentheses and before the parentheses, tabs or spaces, how do we do this indentation, right? It solves all that for us. But it also works as a guide for our newcomers. Because when you're learning a new programming language, one of the things that you want to do is actually want to learn what is the style that the community uses. And you need to go and figure that out from existing code bases. But if you have the formatter, you can write the code, and then you run the formatter, and then the formatter is going to tell you, that's exactly how you should have written the code. And then you can learn with the formatter. Instead of having, you can have a very fast cycle, right, in development and in learning, instead of having a long cycle where you wait for someone to give the feedback or you go actively after somebody else's work, right? But most importantly, it unifies the code written by teams and the community, okay? So let me give an example. So this is code formatted by the formatter. This is a Phoenix controller, and it looks great. It looks like, you know, like very similar to the code that Phoenix would actually generate for you, right? And I must confess, the first time that I run the formatter, it was weird, right? Because the first thing I formatted with the formatter was the formatter source code itself. And it was really weird because I was just working on that code. So I had that code, right, that I just wrote, but it did not look like the code I just wrote. So it was a little bit confusing, okay? But then I got to run the formatter on somebody else's code. And then that code looked like exactly the code I was starting to get familiar. And that's when the formatter immediately clicked for me, right? That's when it was clear why it is so important, okay? Because now I can go to somebody else's code, and it's going to feel like my code. And that's important for us, this collective ownership. Right? So it was a really nice experience. I did not expect that at this point in my life I would have new feelings, but it happened. And it was a really good one. So, so just to show an example, right? So of the benefits we can expect from the formatter. So in Elixir, we have a almost official style guide. And this style guide is maintained by Alexei and Andrea, which are on the Elixir team. And they start to kind of like document the decisions we do in the Elixir code base and reflect on this style guide. So what I did is that after we implemented the formatter, I went to the style guide repository, and I sent a pull request that removed all the things that you no longer need to worry about because the formatter is going to handle that for you. And we can see here that it's removing 550 lines of the style guide documentation. It's reducing the style guide size in more than half, okay? And this is great. It's like a lot of things that we don't need to worry about anymore, right? So before we go on to the next things, I want to talk about the code formatter principles, okay? So what are the design principles behind the formatter? So the first one is that it does not change the code semantics by default. This is very important. So in a way you think about it is that the AST on the input is going to be the same AST of the output. And that's also why we were not able to completely get rid of the style guide because there are things like variable names. So in Elixir, the convention is that variable names, they use snake case, right? Like last underscore name, okay? But if somebody writes last camel case name, right, uppercase name, we cannot do anything about that because if we change the variable name, we're going to change the semantics of the code, and that's a no-no for the code formatter, right? The code formatter cannot afford to potentially break our code, because if we do that, they are not going to trust the formatter, and that's bad news, right? Then they're not going to use it. Okay, so it does not change the semantics of the code by default. But it minimizes configuration. Because if we add a lot of configuration, instead of bike shedding on the style, a lot of people, they're going to bike shed on which configuration they should use. Or even worse, each project is going to pick a different configuration. And then the sense of ownership that we could have, it's lost, because each project is actually different. And no special cases. Remember, one of our foundations, it's extensibility. So the formatter cannot say, well, if the function is named this, I'm going to have this special rule. No, it cannot do that because, so for example, the formatter cannot say, well, if I see the def macro, or if I see def module macro, I'm going to do something special, because we as developers, we can create our own def modules. We can create our own def. We can have something like def call, def cast, like in the X-Actor project. And we need to make them all work the same, right? We cannot special case the language constructs. Those are our principles, and the code formatter is planned for Elixir 1.6 that is coming very likely in January 2018, so really soon. All right. So that's about productivity, right? We're talking about the code formatter. When it comes to maintainability, we are working on this other project that aims to bring data streams and property testing into Elixir. And data streams, so what are data streams? So in Elixir, we have the stream module, which is about lazily generating data, right? So data streams, it's going to extend the Elixir Stream API with data generation functions. Here's an example, very quick example. So if we import the stream data module, now we have this integer generator. And we can say, hey, give me 10 integers, and it's going to generate 10 random integers. We can use the string generator to say, hey, give me 10 ASCII strings, and it's going to give you 10 ASCII strings. And then you can ask, what is this going to be useful for? Okay? And one of the things it's useful for is exactly property testing. But before we talk about property testing, let's talk about the way most of us write tests today, where we write example-based testing. Okay? So in Elixir, and this is a true story, okay? So in Elixir, we have a function called string.contains. And what this function does is that it checks, if the second argument, if the first argument contains the second argument. So when we implemented this function, we had to come up with examples, right? Like, oh, I have the string foo bar, and then I want to check that foo is in that string, right? I want to check that bar is in that string. I want to check that something in the middle is in that string. And we also want to have some cases where it does not match, okay? And that's how we write the tests. And this is great, right? There are a lot of great benefits that we get from example-based testing. We should continue writing example-based testing. The property-based tests, they're not going to replace that, but complement that. And they complement that because of the following limitations we have in example-based testing, which are how to find corner cases, okay? How can we be sure that we are testing everything that we should test? And not only that, when we find corner cases, how can we reason about them? Okay? So for example, if we are writing the string contains function, how should it behave when the second argument is an empty string? Should that return true or false? Right? What if we invert that? Right? This one is easier because a string cannot contain another string that is bigger than the original one, right? So the second one should return false, but the first one, what should return? Okay? And what about this? Does the empty string contain the empty string, right? So we need to remember to test all of those corner cases, right? And when testing it, we need to come up with a good rule to say, how this thing should behave. We need to think what we expect about this code, okay? And with property testing, what we would do is that we would define a property that would say exactly how we expect this code to behave regardless of those examples, right? So if we had property-based testing, this is what we would write. We are going to say, well, I want to check that all the strings that I'm going to use in the left side, and that all the strings that I'm going to use on the right side, if I build a final string, which is the concatenation of the left side and the right side, I want to check that the string is going to contain the left side, and the final string is going to contain the right side, right? This is a property. This should be true no matter what. It cannot be violated. This is a property, Okay, it's like when we are thinking about mathematical operators, we are thinking about associativity and commutativity, right? Those are properties. They are always there, no matter what. Okay, so and with these, we can. So that's going to do is that it is going to use the data generators we were talking about. So here we're using those same data generators. So it's going to use those data generators, and it's going to generate random data, and it's going to execute this assertion a lot of times. You can say, hey, and every time you run your test suite, we are going to run a different set of tests. It's going to generate a bunch of different data. So we're always testing this with new input. And then if you have corner cases, those corner cases, if they're obvious one, like empty strings, maybe you have an error, maybe it returns the wrong result, those, they are going to come up really quickly. But if you have really weird corner case, they're eventually going to come up. Okay? And from here, we can see that all the example of does the empty string belong to a string? It should be true, right? Because both the left side and the right side here, they can be empty strings. So according to this property, if we check if a string contains the empty string, that should be true, because we have this property telling us that that's how it should behave. And this is exactly what happened when we were defining the string contains function. We were not clear how it should behave for those cases. Then Thomas Arts, he came and he said, if I were to write a property for this function, the simplest property, it's going to be this. And then we were able to define exactly how the function should behave. So property-based testing, it's often described as generative testing because we are generating the data instead of coming up with examples. And that's one way to talk about those. But to me, the most important part is that they are useful to describe the invariants in the system, the things that should never change, right? And it leads to thoroughly test software that is designed with intent, okay? And the Stream Data project, it provides data generation primitives. So this is what I want to add to Elixir, Stream Data. It provides data generation primitives and brings stateless property testing to XUnit. But the stateless property testing, which is like that property I just showed you, is just a small part of what we can actually do and express with property tests. Luckily, we have a lot of tools that already exist in the ecosystem today. So you start with Elixir property testing, and then if you need more, you can use tools like QuickCheck that provide more advanced features like stateful testing and model checking and so on. Stream Data is also planned for Elixir 1.6, which should be coming at the beginning of next year. All right, so I think I'm already out of time, so let's do this really fast. So releases, okay? So releases, it's about reliability because release is the best and the safest mechanism to deploy system in Elixir. It gives you log rotation. It guarantees that if the VM shuts down for a reason, it can be started back. It has a lot of safeguards in there and important features, okay? And the thing about releases, so releases is starting, remember I said that I want to also talk about what we expect for the long term? And releases, they are more in the long term, which means you should not have clapped, right? So eventually, it will be part of core. It's not something that we are working on right now, but it's something that was on the list of that we need to have in Elixir since the beginning. And we want to have that, and now I'm explicitly telling this to everybody so you can hold me accountable to that. And while we don't have that, the only reason why we're able to postpone it for so long is because we have the fantastic work of people like Paul that implements distillery, and the Nerves team, they also have improved a lot on how you do deployments on particular platforms. So thanks for their work, we were able to punt this a little bit and focus on other features, right? But it's something that we want to do in the long term, okay? And the last feature I want to talk about is, not feature, but the last line of development, right? So we talk about productivity, maintainability, reliability. It's about what is in Erlang OTP, right? So I'm really glad that we were able to collaborate more closely in the last year. So we saw about the Unicode atom chunk that gives us Unicode atoms, variables, and functions. We saw about the debug info chunk, right, that opened up these new possibilities for Elixir because now we have the Elixir AST stored there, okay? And what we're working now next is to have a cross-language documentation chunk that will allow us to access the Erlang documentation from Elixir, Erlang documentation, the Erlang terminal should be able to access the Elixir documentation, or LLFE, or Alpaca. and any of that, right? But the main story with Erlang and OTP is that, as the platform, right, that we are built on top of continue to grow, it's going to add new possibilities to the language, right? And we're going to continue exploring those possibilities to provide a language that is going to allow all of us to be productive while writing maintainable and reliable software. Thank you. All right, do I have time for questions, or let's do the break? I'll be around, obviously. So if you have questions and you want to talk about any of those things, just come up. Have a good day, everyone.